So today's first question. Prove XCR plus 1, XCR plus 2, YCR plus 1, YCR plus 2, ZCR plus 1, ZCR plus 2 equal to XCR, YCR, ZCR, X plus 1 CR plus 1, Y plus 1 CR plus 1, Z plus 1 CR plus 1, X plus 2 CR plus 2, Y plus 2 CR plus 2, Z plus 2 CR plus 2. Try this. So I will use the property NCR plus NCR plus 1 equal to N plus 1 CR plus 1. If I apply this, for that, how do I apply it? I will add C2 co C2 plus C1 and at the same time C3 co C3 plus C2. What are we going to get? C1 is going to remain same. C2 will be what? Addition of these two. That will be X plus 1 CR plus 1, Y plus 1 CR plus 1, Z plus 1 CR plus 1. Correct? C3 goes to C3 plus C2. That means addition of these two is be what? X plus 1 CR plus 2, Y plus 1 CR plus 2, Z plus 1 CR plus 2. Now what are we going to do, students? See, we need X plus 2, Y plus 2, Z plus 2. So उसके लिए I'm going to add these two. That means C3 goes to C3 plus C2. So XCR, YCR, ZCR, X plus 1 CR plus 1, Y plus 1 CR plus 1, Z plus 1 CR plus 1. Addition of these two will give you what? X plus 2 CR plus 2, Y plus 2 CR plus 2, Z plus 2 CR plus 2. Understood, students? Please write it down. Write this problem and try this at home. काफी nice question. If 2s is equal to a plus b plus c, prove that determinant of a square, s minus a whole square, s minus a whole square, s minus b whole square, b square, s minus b whole square, s minus c whole square, s minus c whole square, c square equal to 2s cube into s minus a into s minus b into s minus c. Like this. And now we are doing this sum. If a comma b comma c are angles of a triangle, angles of triangle ABC, sorry, my mistake. Prove that minus 1 plus cos b, cos a plus cos c, minus 1 plus cos b, cos c plus cos b, minus 1 plus cos a, minus 1 plus cos a, cos b cos a minus 1 is independent of a comma b comma c. Independent of a comma b comma c. Right, students. See, given integral is this. Sorry, given determinant is this. In this, I'm going to apply C1 goes to C1 minus C3, C2 goes to C2 minus C3. Okay. So what does it give? Minus 1 cos C cos B In this, cos b will be gone, cos c will remain. In this, -1 will remain, and cos a will remain. Cos b, cos a, -1. Correct? Now, this is like a symmetric only. So we'll expand it. See the by Sarah's expansion. First, -1, cos c, cos a, cos b. That is cos a, cos b, cos c. Another cos a, cos b, cos c. So that will give you 2 cos a, cos b, cos c. Now we'll see the reverse products. What are the reverse products that we are going to get? Plus cos square b. Actually, it is minus cos square b. We need to multiply with extra minus. Plus cos square a plus cos square c. So we will get cos square a plus cos square b plus cos square c. Correct? Now, how am I going to simplify this? Okay. Understand it, students. Now, what I will do is, see, this is -1 plus cos square b, right? Yes or no? I'll use transformations. That's all, nothing else. 2 cos a, cos b, cos c plus cos square a. See, this is like minus common, 1 minus cos square b. This is minus sin square b plus cos square c. Now, what is cos square a minus sin square b? Cos of a plus b into cos of a minus b. That is 2 cos a, cos b, cos c plus cos of a minus b into cos of a plus b. Since this is a triangle, cos of a plus b is cos of 180 minus c. Correct? Cos of 180 minus c, which is minus cos c. See, cos of a minus b into minus cos c plus cos square c. Correct? Take cos c common. 2 cos a, cos b, cos c minus cos c common. You will get cos of a minus b minus cos c. That is 2 cos a, cos b, cos c minus cos c into cos of a minus b. This will be minus cos c will be plus cos of a plus b. Correct? Now, see, how am I getting this? We know a plus b is 180 minus c. Cos of a plus b is cos of 180 minus c. That is cos of a plus b is minus cos c. So I'm replacing at two places. Okay. One here, cos of a plus b I replace with minus cos c. Another time here, minus cos c I'm replacing with cos of a plus b. Now what I will get in next step? 2 cos a, cos b, cos c minus cos a, sorry, cos c into 2 cos a, cos b. So these two will get cancelled. Answer is 0. So, students? Better. Prove that minus bc, b square plus bc, c square plus bc, a square plus ac, minus ac, c square plus ac, a square plus ab, b square plus ab, minus ab equal to ab plus bc plus ca whole cube. Okay. Shall I discuss this or do you want time to solve?
Sir, we try.
Okay, try it. First step is, I'm going to take a common from this, b common from this, c common from this. If I take, what will happen? ABC minus BC upon A plus C, A plus B, B plus C minus AC upon B, B plus A, C plus B, C plus A minus AB upon C. Okay. Then what will we do is, we'll multiply A to this, B to this, and C to this. Now, once I do that, what will happen? Minus BC, A will be going inside, right? Like AB plus AC, AC plus BC, B is going in the middle. AB plus BC minus AC, BC plus AB, C is in the last. AC plus BC, BC plus AC minus AB. Clear, students? Students, clear?
Yes, sir.
Yes.
Yeah, right on. From here, try it. It is easy now. Like the steps are like straightforward now. Try it.
Or in first
So,
row, it will be AC plus AB, third column.
third column AC plus AB. Thank you. Correct. Correct only. Thank you. So what will we do in the first is, our first step is C1 goes to C1 plus C2 plus C3. If I do that, what will happen? Sorry. R1 goes to R1 plus R2 plus R3. If I do that, what will happen? Addition of this is going to give you AB plus BC plus CA. Check karo. Even AB plus BC plus CA. AB plus BC plus CA. Correct, students? So
Yes.
let's do. We are going to get AB plus BC plus CA, AB plus BC plus CA, AB plus BC plus CA. Now AB plus BC, AC plus BC, minus AC, BC plus AC, BC plus AC, BC plus AB, minus AB. Correct, students? Now take AB plus BC plus CA common. The moment we take that, we will get 3 ones. Correct, students? 1, 1, 1, AB plus BC, AC plus BC, minus AC, BC plus AC, BC plus AB, minus AB. Now, when 3 ones are there, what is the strategy that we follow? Make 2 of them 0. That is what? C2 goes to C2 minus C1. C3 goes to C3 minus C2. If I apply that, what will I get? Here, AB plus BC plus CA. 1, AB plus BC, AC plus BC, 0. If I do this, this will be minus of AC plus AB plus BC. Correct? Na? If I subtract these two, there will be 0, 0, C3 minus C2, right? This will be AB plus BC plus CA. And this will be minus of AB plus BC plus CA. Now, all we are left out is determinant, right? Yes or no, students? Because we'll open with respect to first row. So we will get AB plus BC plus CA into AB plus BC plus CA whole square. Minus out into minus cancel ho jayega. That will be AB plus BC plus CA whole cube. Is it clear, students? Students, is it clear? Right now. If P Q minus Y R minus Z, P minus X Q R minus Z, P minus X Q minus Y R equal to 0, find P upon X plus Q upon Y plus R upon Z equal to 0. Okay. How do I solve this? Observe correspondence. In this, the first step I'm going to do is R2 goes to R2 minus R1. R3 goes to R3 minus R1. What are we going to get? P Q minus Y R minus Z. P minus X minus P. Minus X Y 0. 0. Sorry. R3 minus R1, right? This will be still minus X. P will disappear. Q minus Y minus Q minus Y 0. R minus Z. This will be Z equal to 0. Correct, students? Now let us expand. If I expand, what will I get? This is given as 0. Expand करो. Expand करने से P into YZ आएगा. इसका determinant, right? इसका determinant is YZ. Correct ना? Minus Q minus Y. Minus of Q minus Y into determinant of which? These 4 elements. That is nothing but minus XZ
Yes,
or
sir.
no? So plus xz plus r minus z into determinant of these four elements. That is nothing but AD minus BC, right? 0 plus XY. So XY equal to 0. Students, did you understand?
Yes, sir.
Now, what are we going to do? We are going to divide this with XYZ. Divide with XYZ. Divide by XYZ. What are we going to get? P upon X plus Q upon Y minus Y upon Y. XZ cancel, Y will divide. Plus XYZ say XY cancel, Z is here will divide. R upon Z minus Z upon Z equal to 0. We will get P upon X plus Q upon Y plus R upon Z equal to 2. 1 plus 1. Samjhan students? Right now.
Yes.
If AX plus BY plus 1 equal to 0, AX plus Y plus 1 equal to 0, X plus BY plus 1 equal to 0, X plus Y plus C equal to 0 are concurrent. Find 1 upon 1 minus A plus 1 upon 1 minus B plus 1 upon 1 minus C. Do you remember this is the first time I taught you row operations for this question? I taught you this question in straight lines actually. That was the first time I taught you row operations. Now, what is the concurrency condition for three straight line students? Concurrency condition is sum of coefficient should be 0. A11, 1B1, 1C should be 0. Correct? Now apply
Yes,
row
sir.
transformation. Apply row transformations. That is R2 goes to R2 minus R1. R3 goes to R3 minus R2. Okay. Right. That will give you what? A11, 1 minus A, 0, B minus 1, 1 minus B, 1 minus 1, 0, C minus 1. Correct, students? Now expand. If you expand, what will you get? That will give you A into B minus 1 into C minus 1. Correct, no? Like, I will use Saris expansion. That is also fine, no? A into B minus 1 into C minus 1. 0 plus 1 minus A into 1 minus B. Correct, no? That is this one. Now, reverse products. Reverse products are what? 0, 0, because 1 0 is present means product is 0 only. And product of these two, that is minus 1 minus A into C minus 1 equal to 0. Correct, students? इसको थोड़ा सा करेक्ट कर सकते हैं. A into 1 minus B into 1 minus C कर सकते हैं क्योंकि see everywhere 1 minus A, 1 minus B, 1 minus C are there in the denominator. So I'll correct accordingly. 1 minus A into 1 minus C, like two minuses will come, that will become plus. 1 minus A into 1 minus B, either minus common kar do, 1 minus A into 1 minus C equal to 0. Correct? That will become plus. Minus common liya. Now divide with 1 minus A, 1 minus B, 1 minus C. What will it give? A upon 1 minus A plus 1 upon 1 minus C plus 1 upon 1 minus B equal to 0. Correct, students? Students,
Yes.
correct? Any doubt?
Yes.
So, what is 1 upon 1 minus B plus 1 upon 1 minus C? That is minus A upon 1 minus A. Correct, students? And what we need? We need 1 upon 1 minus A plus 1 upon 1 minus B plus 1 upon 1 minus C. I'm adding 1 upon 1 minus A on both sides. I can do that, right, students? So that is 1. You can see that 1 minus A upon 1 minus A. That is right now, students. Multiplication of determinants. So multiplication of determinants. See, generally, how do we multiply two matrices? A1, A2, B1, B2 if we have it, and C1, C2, D1, D2 if we have it, two matrices. How do we multiply? We multiply it like this. First row will multiply with first column, A1, C1 plus A2, D1. Next, A1, C2 plus A2, D2. B1, C1 plus B2, D1. B1, C2 plus B2, D2. This is the thing, right? First row, first column, first row, second column. Second row, first column, second row, second column. Correct, students? That's what we are going to do.
Yes.
Now, imagine if they are determinants, they are not matrices. The calculation can be same exactly like this. Matlab, we can maintain like this. This is true. This is correct. Our original matrix multiplication, exactly, row into column, row into column, row into column. But one advantage we have in determinants is both are square forms only. Like in matrices, they can be rectangle forms also. Order need not be same. Here they are order must be same, and they are of same order also. Square matrices. Now, one more thing that we have is like you don't need to multiply row with column only in determinants. You can multiply row with row also. That is here. A1 C1 plus A2 C2, first row with second row. A1 D1 plus A2 D2, second row with first row. B1 C1 plus B2 C2, B1 D1 plus B2 D2. Is it clear, students? First row with first row with second row with first row, second row with second row. Any doubt in this, students?
No,
Students, any doubt? See, this can easily happen. I can prove this easily because we know determinant ka. See, determinant of A equal to determinant of A transpose, right? If I take the transpose of the first determinant, is going to be same. A second determinant is going to be, value is going to be same. Now, if I multiply row with column, I'm going to get this one only. Check it out. Students, yes or no?
Yes, sir.
yes,
So basically, we like one thing you can understand or remember is in determinants, you can multiply row also, row column also, but do only one of them. Don't do other for row and other for row column. Is it clear, students?
Yes.
Write it down. I'll do problems on this, how this can be applied in solving the determinants. Okay. Generally, now when we solve the determinants, we don't do from LHS to RHS. आपको वैसा question नहीं आने वाला है. They'll give you two determinants and they'll ask, see, please multiply and tell us answer. No, that's not going to happen. Okay. How this concept can be used, I'll explain you. Right on, students. Now let's come back to our original problem. Like if we have solved this some multiple times, A plus B, B plus C, C plus A, B plus C, C plus A plus B, C plus A plus B, B plus C. Correct, students? We wrote it as 2 times ABC, BCA, CAB. Correct, students?
yes,
Now let me show you by another method. Here, by multiplication of determinants. How am I going to write it? I'm going to split this determinant that we have on LHS into multiplication of two determinants. One of them is this one. Okay. So this I'm going to write it as ABC, BCA, CAB into. अब ध्यान से सोचो, row या row column, one of them, fix it. What shall we do? Row or row column? Tell me, one of you.
row,
Row. Okay. See, if I multiply this with this, I'm going to get this one. Correct, no, students? मतलब A के साथ 1 रहना है, B के साथ 1 रहना है, C should not be there. Correct, students?
Yes, sir.
Students, yes.
Yes.
Correct. Now, if I multiply first row with second row, I'm going to get this. That means what should be there? A should not be there.
0, 1,
B
1.
के साथ 1, 0, 1, 1. If I multiply this with this, I'm going to get this. That means 1, 0, 1. Now let us see whether it is working with other rows or not. So I'll make it disappear. I'll multiply this with this. This with the first row, B plus C, perfect. C plus A, perfect. A plus B, perfect. Of course, it will work with the third one also. We just did the cyclicity. Did you understand, students?
Yes.
Yes.
So we just need to do what? Iska value evaluate karna hai. That's what. We'll apply Sarah's method. 1 plus 1 plus 0. So 2. Baki tino reverse products are zeros. Check it out. All reverse products are 0. 0, 0, 0. So answer is 2. 2 times ABC, BC, AC. Is it clear, students?
Yes.
Right on. And thoda write your explanation. Pehla question hai. When you revise, you need to understand. Okay, write your explanation properly. If P, Q, R, A, B, C belong to R, real numbers, prove that cos of P minus Q, cos of A minus P, cos of A minus P, cos of B minus P, cos of C minus P, cos of A minus Q, cos of B minus Q, cos of C minus Q, cos of A minus R, cos of B minus R, cos of C minus R, determinant equal to 0. Okay, prove that this determinant value is 0, irrespective of P, Q, R and ABC. Okay, let me explain. So what I will try to do is, I'm going to expand this. This big determinant is there now. I'm going to expand. I meant the formulas of cos of A minus B formula I'm going to write. Uske baad, I'll try to split. So cos of A minus B formula is what? Cos A cos B plus sin A sin B. So cos A cos B plus B nahi hai, P hai, sin A sin P. Correct, na, students?
Yes.
Niche what will be there? Cos A cos Q plus sin A sin Q. Cos A cos R plus sin A sin R. Here cos B cos P plus sin B sin P. Cos B cos Q plus sin B sin Q. Cos B cos R plus sin B sin R. Cos C cos P plus sin C sin P. Cos C cos Q plus sin C sin Q. Cos C cos R plus sin C sin R. Correct, students? Now I'm going to split this into two determinants. Dhyan se dekho. How am I going to split into two different determinants? See, one thing that I'll tell you. First row ko, see row, let's go for row only. First row ko, first row se multiply karenge, then this will come. Second row se multiply karenge, this will come. Third row se multiply karenge, then this will come. Correct, students? Here nothing is fixed. We don't have anything in mind. But one observation I can tell you, elements which are common to all three of this must be here.
Yes.
Correct, na, students? तीनों को कॉमन आ रहा है, वो कहां से आ रहा है? इधर से ही आना चाहिए. Yes or no? Which are common? Can tell me? Can somebody tell me?
Cos P sin P.
Cos P sin P are common. So that's what is going to stay here. Cos P sin P 0. Correct, na? Any doubt? So here what should come? Cos A sin A 0. Cos B sin B 0. Cos C sin C 0. देखो सब आ रहा है. Abhi? Samjhana students?
Yes, sir.
Yes.
What elements are common for second row? Second row पूरा observe करो. What elements are common?
Cos q sin.
Cos q sin q. So cos q sin q 0. Of course, third row के लिए cos r sin r 0. We successfully split into two determinants. And दोनों determinants का value 0 है. 0. And if somebody comes and tell me, sir, what if I write 1, 2, 3 here? Will that change? No, nothing. Answer will still be 0. Because other determinant is 0, right? Third number can be anything. It doesn't matter. Clear, students?
Yes.
Right. One cos of beta minus alpha, cos of gamma minus alpha, cos of alpha minus beta, 1 cos of gamma minus beta, cos of alpha minus gamma, cos of beta minus gamma, 1 equal to 0. Similar question as previous one. Okay. But here PQR की जगह alpha beta gamma आता है and ABC की जगह also alpha beta gamma only आता है. So your first step is what you know, writing that one as cos of alpha minus alpha, cos of beta minus alpha, cos of gamma minus alpha, cos of alpha minus beta, cos of beta minus beta, cos of gamma minus beta, cos of gamma alpha minus gamma, cos of beta minus gamma, cos of gamma minus gamma. Correct, students? What will be the next step? Of course, you will write it as cos alpha plus sin alpha, cos beta cos alpha plus sin beta sin alpha, cos gamma cos alpha plus sin gamma sin alpha. This will be cos alpha cos beta plus sin alpha sin beta, cos alpha cos, writing completely, cos alpha cos gamma plus sin alpha sin gamma, cos beta plus sin beta sin beta, cos beta cos gamma plus sin beta sin gamma, cos gamma cos beta plus sin gamma sin beta, cos gamma sin gamma sin gamma. Correct? So this will be split into what? Cos gamma, cos alpha sin alpha 0, cos beta sin beta 0, cos gamma sin gamma 0. We have to multiply with what? First one cos alpha sin alpha 0. For second one cos beta sin beta 0, cos gamma sin gamma 0. Correct, friends? Answer is 0. Is it clear?
Yes.
So this is clear. Right. Prove determinant of 2 a plus b plus c plus d, ab plus cd, a plus b plus c plus d, ab plus cd, 2 times a plus b into c plus d, ab into c plus d plus cd into a plus b, ab into c plus d plus cd into a plus b, 2abcd equal to 0. Try this. There's one typo. Here it is AB plus CD. A plus B plus C plus D, AB plus CD. I think rest of it is fine. Yeah. So 2A plus B plus C plus D, AB plus CD, A plus B plus C plus D, 2 times AB plus this one, right? So how do I split it is, I'm going to split it like this. See, 2 को लिखूंगा 1 1 0 1 1 0 and I need a plus b c plus d. Correct now. So even the next in that is also a plus b c plus d are phrases are there. So I'm going to write. See, this is just an experiment. Okay, we don't know whether this will work or not. See, first row is coming, not a problem. A b c d 0. I'll keep it like this. Now I will think this one. How do I split it? A plus b c plus d, right? So if I write a plus b c plus d 0, first row, fine. When I multiply this with what I'm getting a plus b whole square plus c plus d whole square. But that's not what we have. We have multiplication of a plus b into c plus d. That means I need to interchange. So what will I do is, I'm going to interchange these two and write it as c plus d, a plus b. Will it help? Let us see. The first one is not going to change. Multiplication of these two, a plus b into c plus d plus a plus b into c plus d. Okay, it's working. Fine. Second element is coming. Now I'll multiply with this. We will get ab into c plus d, ab into c plus d, cd into a plus b. Yeah, it's working properly. Now let me see like this. A, B, C, D, 0. This into first row, it's working. But this into this is giving us what? Multiply them. AB into A plus B plus CD into C plus D. Is it what we have here, students?
No, sir.
No, sir.
Reverse is there. Correct, na? So let us reverse here also. CD, AB. Now let's check. Is it working? Yes, it's working. Now, is this working here also for the fourth element? What we'll get? CDAB plus ABCD. Of course, it's working here also. So this is a splitting. Splitting is complete. Samjhana, students?
Yes.
Yes,
Yes.
sir.
Yeah. This is answer is 0, of course. One entire column is 0 in both of them. Clear? Please write it down.